Okay, so this is the second part of this section 4F. For exercise 4F. Now look at a couple of questions only. First, start with question 4. Now find a value of t or values, we're not sure, if these two vectors are perpendicular. Now, so how do we resolve this? Let us think. In part 1, we spoke of this result. If theta is the angle between the vectors A and B, and we can write them like that. So suppose you have a vector A and vector B, both of them animate from a same point as theta here. Now, because the formula says A dot B is equal to this times this cosine theta, and so this is just a value, right? So as long as the vector is non-zero, so it will have value. So okay, it's fine, this is a value. So probably we can do something with cosine theta. I suppose we get a situation where these two vectors are just perpendicular, and so this is 90 degrees or pi over 2. But what is cosine pi over 2? So you get this cosine pi over 2 or cosine 90 is actually, you got it, it's 0. And so this is equal to 0. So this gives us an idea to resolve this problem by using this. So this is how we start. We know now that if the two vectors are perpendicular, then the dot product of these two vectors is 0. So since these two are perpendicular, we dot them, and because they are perpendicular, so what would the outcome be? Yes, it is equivalent to 0. Right, and so all we need to do is now just do the dot product, and you get 60, right, and then plus 3 and plus negative 40, and this is equivalent to 0, and just perform the usual algebra, and you get negative 3 over 2. Isn't it wonderful? This is a very, very useful result to show that two vectors are perpendicular. Let's look at one more problem in this second part of this section 4F. Now consider a triangle ABC, question 7, okay, at which A is ABC given the coordinates. Using scalar product only, show that the triangle is right angle. I'm not going to finish doing this, but I'm giving you some hint, and because if indeed ABC is I'm just simply sketching, I could be wrong sketch, right? You just beware of that. It could, because the right angle triangle could look like this. Okay, so you have to, it could be any of this, but it doesn't matter, just use this, use this as to explain what I want to say. And so if this is indeed right angle, so what we get here is then if you can find this vector, and we find this vector, and we dot them, if the result is 0, then we are done, right? It's very simple. So what you need to do is you probably find this, okay, you find AB, you will probably need to find BC, I think you need to find AC also, and you perform the dot, and you dot this, you do this, dot BC. If it's 0, then you're done. Then you just say, therefore ABC is a right angle triangle, or you just, or if it's not 0, then you continue on by doing this dot these two, and if it's 0, then again you can make this conclusion. Alright, isn't it simple? So okay, I hope you try the other questions, especially question 8 and 9, and see you in third video, and all the best.